In Akulchandi, George Sudarshan was an outstanding Indian theoretical physicist and a professor at the University of Texas. He was born in Kottayam, in 16th of September 1931. He studied at CMS College Kottayam and graduated with honours from the Madras Christian College in 1951. He obtained his master's degree at the University of Madras in 1952. He moved to Tata Institute of Fundamental Research, TIFR, and worked there for a brief period with Homi Bhabha as well as others. Subsequently, he moved to University of Rochester in New York to work under Robert Marshak as a graduate student. Despite being raised in a Syrian Christian family, he later left the religion in large part due to marrying Lalitha, a Hindu fellow student in 1954. In 1958, he received his PhD degree from the University of Rochester. At this point he moved to Harvard University to join Julian Schwinner as a postdoctoral fellow. His major contributions are: 1. Quantum theory for tachyons, particles that could possibly move faster than light, which challenged Einstein's assertion that nothing with mass can travel faster than the speed of light because of the infinite energy required. The theory was never fully developed. 2. A theory of the weak force, a theory about weak interaction between subatomic particles. This weak nuclear force fundamentally preferred one-handedness over the other, where V is a vector and A is a pseudo-vector, while working on his PhD thesis. 3. Glauber-Sudarshan P representation, a quantum mechanical description of photons to explain the quantum properties of light. 4. The quantum Zeno effect is a phenomenon in quantum physics where observing a particle prevents it from decaying as it would in the absence of the observation. 5. Optical coherence. While the distinction of introducing coherent states as basic entities to describe optical fields certainly goes to Glauber, the possibility of using them to describe all optical fields, of all intensities, through the diagonal representation is certainly due to Sudarshan. Thus there is no need to extract the classical limit, as stated in the Nobel citation. Sudarshan's work is not merely a mathematical formalism. Other major contributions are: open quantum system, spin statistics theorem. His research interests spanned a wide range of fields from particle physics, quantum optics, and quantum field theory to quantum information theory, gauge theories and classical mechanics.
Photographic emulsions technique had just been developed and been used, so the tracks of many particles are seen in this one. And unlike bubble chamber pictures, these pictures indicate photographic grains which are developed, and they don't go in a straight line. They somehow or other meander around it. And one of the problems I tried was to use this to determine the mass of the particle by finding it as a function of the distance. Usually, the particles which are sort of dying somewhere along the line, so they would be slowed down and there would be a lot more ionization.
Nobel Prize controversies. The renowned physicist was even recommended for the Nobel Prize several times but never awarded. A theory was a vital contribution, should have led straight to a Nobel Prize for its authors, but this discovery got bogged down in controversy. Marshak and Sudarshan's paper was presented in a conference proceedings in 1957. But 6 months later, the much more famous Caltech duo of Richard Feynman and Murray Gell-Mann published a paper with the same result, derived in a different way. The controversy over priority has lasted to the present day. As a result, the Nobel Committee played safe by deciding not to award this discovery at all, despite multiple nominations for Marshak and Sudarshan over the years. Glauber, however, did not initially accept this representation, and it was only later, after correspondence with Sudarshan, that he reinvented it under the name P representation. To his amazement and horror, the then septuagenarian Sudarshan found that the 2005 Nobel Prize had been awarded to Roy J. Glauber for his work in quantum optics, and that his own seminal work had been passed over again. Awards: ICTP Dirac Medal, 2010, Padma Vibhushan, 2007, Major Anna Prize, 2006, Twas Prize, 1985, Bose Medal, 1977, Padma Bhushan, 1976, C. Veeramani Award, 1970. He passed away on the 13th of May 2018 at the age of 86.